All right, let's talk about AI prompts. If you've ever tried to get a consistent answer from an AI and felt like you were doing some kind of magic instead of engineering, you are definitely in the right place. Today, we're going to ditch the guesswork and learn how to actually engineer prompts that are reliable, robust, and predictable. It's super frustrating, right? You ask the same question twice, you get two totally different answers. Or you give it a really specific instruction, and the model just ignores it. That unpredictability is exactly what we're here to solve. So what is actually happening under the hood? Okay, first things first. We have to change how we think about the word prompt. It is not just the question you type in. A real engineered prompt is a whole package. You've got the system prompt, which sets the rules of the game. You have the user prompt, which is your specific command. You've got examples to show the AI what good looks like. And you have context, so it has the right information. Thinking in these components, that's the first real step to taking back control. So, let's start by peeling back the curtain a little bit and look at some of the hidden complexities that can really trip you up, even if you've been doing this for a while. Now, this one is super important. It's what you might call a hidden foot gun. See, different models expect their inputs formatted in very, very specific ways, with special tokens, special structures. If you don't match that template perfectly, the model doesn't crash or give you an error. No, it just silently fails, giving you an answer that looks okay, but is actually much, much lower quality. Next up, let's get clear on the system prompt versus the user prompt. Think of the system prompt as the AI's constitution. It's the set of rules for the entire conversation. The user prompt is just your turn-by-turn question. And 9 times out of 10, that system prompt has way more power, either because it comes first or because the model has literally been trained to listen to it more carefully. We've also seen this just mind-boggling explosion in context length. I mean, look at this chart. We've gone from models that could remember maybe a couple of paragraphs to models that can basically read an entire novel in a single go. It feels like a superpower, right? But there's a catch. And here's the catch. Just because a model can see millions of tokens doesn't mean it pays equal attention to all of them. Research shows that they pay a lot of attention to the beginning of the prompt and a lot of attention to the end. But important stuff you stick in that vast middle, yeah, that can get completely lost or ignored. It's a real problem called lost in the middle.
Okay, so now that we know the pitfalls, what are the fundamental techniques that actually work time and time again? Let's build out our core toolkit.
These 5 things right here are your bread and butter. Be painfully explicit. Assign a persona when the tone really matters. Give it examples. Show, don't just tell. Make sure it has the information it needs to answer correctly. And if you need structured data back, you have to specify the exact format. These aren't fancy tricks, they're just solid engineering. Let's make this real with an example. So say you ask an AI to explain the tooth fairy to a kid. Without any guidance, you're likely to get a dry, boring, encyclopedic answer about cultural traditions. It completely misses the point. But now, look at this. All we did was add one single example of the kind of whimsical answer we wanted, a technique called few-shot prompting. And boom, the model's entire tone and style just flips. It gets it. It understands the assignment and gives you a perfect magical story for a child.
Okay, so we've got single prompts down. Let's level up. How do we start architecting entire systems for tasks that are way more complex and have multiple steps?
The big idea here is don't try to build one giant monster prompt that does everything. Break the problem down. This is called prompt decomposition. In this customer support bot example, we first use a really simple, cheap prompt just to figure out what the user wants. Is it a billing question? Technical support? Then we route that to a totally separate, specialized prompt that is an expert at handling just that one thing. Now, this approach isn't a free lunch. There are definitely trade-offs. Breaking things down makes each little piece way easier to test and debug, for sure. But it can add a little bit of latency, and maybe increase your costs because you're making more API calls. It's an architectural decision, and you have to weigh these pros and cons. And for those really, really tough reasoning problems, you can use tricks that basically force the model to slow down and think. You can ask it to work things out step by step, that's called chain of thought, or you can even have it write a first draft and then prompt it to critique its own work. These techniques can have a huge impact on the quality of the final answer. This brings us to a really critical mindset shift. We have to stop treating our prompts like disposable text files. They are a core part of your software, and they deserve the same discipline as your code.
So what does that look like in practice? It's a simple, iterative loop that should look really familiar to any developer. You see a failure, you come up with a fix and update the prompt, you run it against your tests.
And you repeat. It's not about guessing. It's about methodical, systematic improvement. And please, get your prompts out of your application code. Store them separately in an organized, version-controlled way. This makes them reusable, way easier to test, and it even lets non-engineers on your team help write and maintain them. And always include metadata. What model was this for? Who wrote it? What version is it? This is just professional-grade engineering.
All right, final section, and it's a big one: security. Once you built this amazing system, you need to know how to defend it from people trying to misuse it. This right here might be the single most important rule of prompt security. Do not depend on your prompt being a secret. It's not a password. People will find ways to get it out of your system. So you have to write it assuming that one day it will be posted publicly on the internet.
And trust me, attackers are getting incredibly creative. They'll use everything from weird misspellings and Unicode characters to something called content smuggling, where they hide a malicious command inside a totally innocent request, like, hey, write me a poem about this bad thing. You have to know what you're up against. So what's our best defense? Well, it's something called an instruction hierarchy, which is actually built into the model itself. The model is fine-tuned to trust instructions in a specific order. The system prompt is king. The user's prompt is secondary. And any text coming back from a tool or an API, that's treated as the least trustworthy of all. This simple hierarchy shuts down a whole class of attacks automatically. And that brings us to the final thought I want to leave you with. As you go back to building your own AI applications, ask yourself this: is the prompt you're writing a clear, robust, defensible instruction? Or is it a fragile, unpredictable liability just waiting to cause problems? Adopting an engineering mindset makes all the difference in the world. Thanks for tuning in.